Hey, good morning. Welcome to
FamilyMath171a.
FamilyMath171a. We have spent the week talking about platonic solids and their symmetries, right? And we have one more to do. What is it?
The icosahedron.
The icosahedron. So we're going to be doing that in the next video, the symmetries. But we have studied the tetrahedron, the cube, the octahedron, the dodecahedron. And one of the things we did on all of those is we counted. We didn't do it in all the films, but we did it every time. Anyway, we counted the faces, the edges, and the vertices, right?
Yeah.
So let's do that for the icosahedron. How many faces does it have?
Well, it's 20.
Okay. How do you know that?
Because the Dungeons and Dragons die is shaped like this is called the D20.
That seems like a pretty good reason.
Yeah.
Okay. What's another way you could know that that has 20?
Well, you could count them.
You could count them. All right, so 20 faces. You want to do edges or vertices
I'll do
next?
edges.
Edges next. Okay. How many edges does it have?
Well, the edges, you can...
Yeah, no, let me brother talk.
Well, you can do the same thing like with the dodecahedron. You can count the edges here, 5, 10, and then this part, 15, 20. Then there's this part in the middle, which is 10,
I don't really get that.
30.
30, so you counted 30, okay. What was your way of counting?
Well, there's 3 edges per face.
Okay,
So 60 edges, but each edge shares 2 faces.
okay.
So 30.
Oh, okay. That's also a very good way of counting. Each edge is part of 2 triangles.
Yeah.
Right? So if we take the number of triangles, which is 20, times 3, the number of triangle edges, we get 60. And then we divide by 2 because we counted each edge twice.
Yeah.
But your way of counting was good too. And luckily, both times we got 30. And finally, the vertices.
Well, the
It's
vertices,
where the balls are.
Okay?
you can do the same thing. But up here there's a center ball.
All right.
There's a top ball and a bottom ball. There's 5 plus 1, which is 6, and 5 plus 1, which is 6 on the bottom too, and you add them up and there's 2.
Okay. Now one of our edges came out, unfortunately. That's all right. Can you think of any other way we could count the vertices?
Well, you could do the same thing, but there's 3 vertices. You could say 60 vertices, but each vertice shares 5 faces. So
Okay.
60 divided by 5 is 12.
Oh, very good. So we could say each triangle
It's 3.
has 3 vertices, so we get 60. 20 times 3.
Yeah.
But there's 5-fold symmetry. So we have to divide by 5. Each vertex is part of 5 triangles. Do you see that?
Yeah.
All right, so good. So 12. Okay. Now, so this is for the icosahedron?
Yeah.
Yep.
Let's do the cube. Okay. Faces, edges, and vertices.
The cube, well, the faces, there's 6 faces.
6.
And then for the edges, there's 4 on the top, 4 on the bottom, and 4 in the middle.
All right.
So there's 12.
And for the vertices, you could do the same thing.
All right.
4 on
You
the
could
top.
say you could say there's 24 vertices because there's 4 to a cube times 6. 4 to a square times 6 faces.
All right.
But each face shares 3.
Okay.
So 8.
All right. Okay. Very good. So, believe it or not, there's actually a formula that connects these things. And it was discovered by Euler, and apparently, remember Euler?
Yeah.
What's he famous for? What do you know him for?
E.
E. Okay. You ready to see it?
Yeah.
Okay. So it relates the faces, edges, and the vertices. So can you see any relationship between them? It's not super easy to see.
Well, they're all multiples of 2.
They're all even.
They're all even, yeah.
Yeah.
Well, maybe these 2 are the same.
Yeah, it's a tricky one. I'm just gonna tell you what it is. It's faces, plus vertices minus edges.
Faces plus vertices minus is equal.
What does that equal over here?
Well, it's 30. It's 2.
Okay. What does it equal over here?
It equals. It's
It's
2.
2.
Gonna do it for one more shape just to see?
Sure.
Let's do it for a simple one. Do we have that? Do we have the tetrahedron?
Sure. Yeah.
Okay. How many faces?
It has
4.
4 faces. It
How many
has.
edges?
There's
6 edges.
6 edges. How many vertices?
then there's 4.
Okay.
So
Faces plus vertices.
and that's 8 minus 6.
2.
Cool.
It's pretty neat, right?
Yeah.
So that's a famous formula, another famous formula discovered by Euler. Can you think of another mathematician whose name you've heard a lot associated with some fun formulas?
Euclid.
Euclid? Not as many formulas, but a lot of, what did Euclid study?
Geometry.
Geometry. Anyone else?
Einstein.
Einstein?
I think there's like one other
Yeah, there is one other famous mathematician.
that begins with E.
E? It begins with E? Euler, Euclid, Einstein?
Plato?
Plato was more of a philosopher. Okay, well, we'll learn a lot about it. We'll learn some more famous mathematician names over time. Anyway, let's go to our kitchen table and look at the symmetries, and we'll see how many we got. Okay?
Yeah.
Alright.